Good morning, science family. We want to cover today something called the properties of matter. The two main focus here is that we're going to find the difference between physical and chemical properties and physical and chemical changes. This will overlap well since we already know what matter is, and we're going to start looking at the properties that define specific different things or pieces of matter. So let's go. Say you're walking down the hallway and you recognize a friend. The question is, how do you really know that it's them? Is it the color of their hair, or maybe there's someone thin or there's someone short, maybe they have a mohawk like this kid right here? The reason being, you can recognize them because of their physical properties. So let's get deeper into that. What does that really mean, physical properties? Physical properties basically just tell you the characteristic of a substance. But what does that mean? It means that the things you notice about them. For example, if we look at this skunk right here outside, you know skunk has a certain scent that they carry. They also take up a certain amount of space, so we look at size. You can look at an object and look at its density, whether it floats in water or not, or if it's a solid, liquid, or gas, what phase it's in, or what its color is. All of those things are characteristics or examples of physical properties. Now, physical properties can change in a substance without the substance actually changing. So what does that mean? Well, think about like water. If we have water in the liquid form and we freeze it, eventually we can turn that water from liquid to solid, like an ice cube. So it's still water, but it went from liquid to solid, so it went through a physical change. So we can change the physical properties of objects without changing the actual substance that it is. A chemical property is something different. It shows the ability to change into a completely new substance. So a chemical property is a property that an object has that allows it to change into something else. So if the object can react with something, that's a chemical property. Or if it cannot react, think about like jewelry. The fact that your jewelry just sits on your fingers or in your ears and it doesn't really react, that's a really good chemical property. You don't want it to react with your skin or make it change your skin, turn colors or something like that. So something being non-reactive is really helpful. Think of like coins. So a quarter, it's not very reactive, which is good because we want the quarter to last a long time so that if we use it 4 years later after we get it, it's still usable. If it was highly reactive, another chemical property, then maybe it would have reacted so much that the quarter would be gone by now, which would not be beneficial. What if something can burn? That's a chemical property because once something burns, it changes into a completely new substance. What if something can rust? That's a chemical property because when an object rusts, it changes into a completely new substance. What if something decomposes or breaks down? Perfect. It's no longer the same object when it breaks down. Let's think about something as simple as hair shampoo. And let's think about some of their physical versus chemical properties. So physical seems to be more obvious to us, so let's start with that. Physical properties of the shampoo may that it has a certain smell. Maybe it has a coconut scent to it. Maybe it has a color to it. Maybe it's white or translucent, or maybe it's purple or pink. It has a texture to it, right? It's squishy, it can be thick, it's slippery. All of those are physical properties of the shampoo. Now, the chemical properties of shampoo is a little harder to do at first because you have to think about, well, what can or can't it do to create a new substance? And we aren't completely familiar with that yet, and we'll get better as time goes on. But think about something as simple as the fact that it won't burn your scalp. That's a chemical property, meaning that the shampoo won't react with your skin in a way that'll burn it. Also, how about the fact that it won't react with water, which is a good thing. If it did react with water, it might create a large amount of heat, which could burn you as well. So the fact that it's not very reactive, or that the shampoo has what we call low reactivity, that is a very important chemical property. Okay? So we talked about physical and chemical properties. Now let's talk about physical and chemical changes. As we said, if you change the physical property, the substance is still going to stay the same. So think about it. If I dye my hair blue, don't worry about the process of dyeing your hair, but the fact that yesterday my hair was blonde and today my hair is blue. Is it still hair? Yes. Is it a different color? Yes, but it's still my hair. So that's a physical change. What about taking a piece of paper and cutting it in half? Is it still paper? Yes. Is it in more pieces now? Yes. But it's still paper. So a physical change, the substance stays the same. Chemical change, that's a little bit different. When an object goes through a chemical change, you have a completely new substance. So for example, on an old car that develops rust, that iron on the door that's just exposed to oxygen eventually reacts with the oxygen and you form that crusty reddish orange rust. That iron is no longer iron. It's a combination or a compound between iron and oxygen. So that is now a new substance. Therefore, it went through a chemical change. What about cooked chicken that is now in the garbage can? You let that chicken sit in the garbage for weeks and weeks, and eventually it becomes what? Like a puddle of sludge, which is disgusting, right? But the idea is that it's no longer chicken. It's decomposed, the bacteria ate away at it. It's now some new nasty, sloppy substance. That went through a chemical change as well. So let's look at this. If you go from ice to water, which we know as melting, is that a physical or a chemical change? Well, ask yourself, is the ice and water still the same substance? Is it still H2O, water? Yes. So even though it went through a change, a phase change from solid to liquid, it's still H2O, water. So that means this is a physical change because even though it changed, it's still the same substance. How about something like toasting a marshmallow in a fire? And if you're like some people, you like to burn it so that the marshmallow gets all black and full of ashes. Is that a chemical or a physical change? Well, the marshmallow is now burnt and it's no longer a marshmallow, it's a pile of ashes. So is that a marshmallow anymore? No. So since the substance changed, that is considered a chemical change. There is one other type of change that we will learn, not in this unit, but later in the school year, and that's a nuclear change. Sometimes inside an atom, which we'll go into further here soon, but inside the nucleus of the atom, it can break down. And when it does, it forms a completely new element and it gives off energy, which we call radiation. That's called a nuclear change. So sometimes objects don't go through a physical change or chemical change. They actually go through a nuclear change, which means the element has turned into some completely new one. All right? And again, we'll get into that later in the year, but just wanted to let you know there is one other change. But focus on chemical and physical properties and changes for now, and you should be good. All right, science family, take care, and thanks for listening.